Good morning, everyone, and welcome to Open Source Summit India. I hope you are well caffeinated and like you're up for a very exciting day of open source. So this is our talk today. It's more than an SBOM button for compliance, and we will be looking at SBOM quality and what matters when you are looking for tooling that produces a great quality SBOM. So this is the agenda for here. We do a round of introductions. We talk a bit about software bill of materials, what it is, and what are the minimum requirements, all of that. Then we look for all the issues and things to look out for if you want a good quality SBOM, and how About Code is helping do that in an open source, open data manner. So a bit about me. I am a core maintainer of ScanCode. This is a ScanCode toolkit is a command line tool, and ScanCode.io is a server for software composition analysis. We also help contribute and maintain other About Code tools which work for license compliance and security compliance. I personally work mostly on license detection, package detection, and sort of quality on binary scanning, SBOMs, and how I got here was I participated in GSOC in 2020 at About Code. About Code is a FOSS organization, so it participates in GSOC, and we still do GSOC. We are an organization now. We are mentors and organization admins here. We have Keshav here, who is also a mentor from About Code, and we maintain About Code tools. Here are my links, and so let's talk a bit about Code. Everything we do in About Code is fully free and open source. Our mission is to provide open source tools and open knowledge bases, which helps you look for what is in your software. And we give you simple and practical standards to do that. And we also have applications that cater for legal and security business users. So these are people in our organization who are handling large-scale packages and inventorying and looking for compliance issues or risk in them. So we are not the only ones in About Code. There is a lot of other folks who are experts in SCA, and they have been in this domain for a lot longer than we have. If you know about package URL, SPDX, CycloneDX, and clearly defined, these are projects that were either started by people from About Code, or they were started in our tools for our own use, and now they are a bit popular. NexB is a professional services business that we provide consulting and sponsor development for About Code tools. Whatever we do there is also always released as open source, and we provide technical advisory. So we help companies look into what is in their software, do build audits and software security or licensing audits for them. This is how we help sustain the open source projects. We also are beneficiaries of some grants from NLNet Foundation and other foundations, which helps us do the open source work and maintain these great tools. So let's start with software bill of materials. So here, the goal is always to know what is in the software and be very transparent about it. So we all have a lot of smart appliances, a lot of digital things every day around us, like a modem, smart appliances, our cars which have digital things in them. And if you see, many of them are sometimes, especially modems, running decades-old software with probably many bugs and vulnerabilities in them. So as a whole, transparency will only help get us more secure and more resilient digital products and digital tools. So I think software bill of materials helps with that. So if we look at software bill of materials, it is often compared with a recipe for food. It is like, all the lists of ingredients that is present in a, for food in a recipe. But we think that SBOM is not really a parts list. It's more of a build audit and looking into your software, because, of course, at the end of it, the SBOM has a parts list. It has a list of components and where you can get them and other elements on that. But to get a SBOM, you really need to get a good quality SBOM. You need to really look at your build systems, how you are getting software, how it is being built, and then that gives you a good quality SBOM. Knowledge about your build systems and origin about your code, right? So that's our view on that. What we can do as a specification level to help this, there are two standards for SBOMs, SPDX and CycloneDX. SPDX is a Linux Foundation project which started originally looking into licensing more. They have a license list which compiles a lot of licenses which are seen. It's a community project. CycloneDX, this is a bit more security focused, started from OWASP Foundation, and we participate in both these communities heavily. SPDX was co-founded by also the co-founder of About Code. And CycloneDX we participate in heavily because package URL and universe, these standards are being adopted by CycloneDX, and they are going for a ECMA specification. And the SPDX has a ISO specification. So these are all standards that are specified. And so package URL, we will talk about that more in a later slide. But it is a list. It is a unique identifier which uniquely identifies one package and helps you get data about it. So why do we need a SBOM? Firstly, of course, there's a transparency and knowing what is in your software. But these days, we are seeing also a lot of regulations which mandate or recommend SBOMs. So we have the CRA in EU, which came into effect, and it mandates SBOM generation for a lot of participants. And also, there's a US executive order about SBOMs. We also are in India, so we'll talk about Indian regulations. SEBI, which is the Stock Exchange and Securities Board of India, they have mandated SBOMs in a regulation that's known as Cybersecurity and Cyber Resilience Framework, CSCRF, where all the SEBI-regulated entities, so digital stockbrokers, authenticators, or all kinds of regulated entities, they need to provide an SBOM if they are building any digital tools, or they have to do vulnerability disclosure, all that sort of things, right? So that also, CERT India has a guideline for SBOMs. It has recently, this month only, they released a version 2.0, which apart from SBOM also talks about hardware bill of materials, cryptographic bill of materials, AI bill of materials. So we are seeing more and more adoption across the whole industry because of these guidelines, and also because of regulations, because they are required in somewhere else. And in this world where there's a lot of multinational corporations, of course, if there is some regulation somewhere, usually all the other parts of the world also, they follow through because they want to do business with those countries or organizations. Now, what is a package URL? So this was started in scan code to uniquely identify packages. Here are the type, namespace, name, version. These are important parts for this. The goal is to first uniquely identify a package and also to get data about it from an ecosystem or somewhere where that data is there. So licensing data, security data, or something. So here you see some examples. So Debian packages. So the namespace, the type is the ecosystem. For example, it can be Debian, GitHub, NPM, Maven. These are all repositories which has to follow some conditions. For example, the name plus namespace must be unique so that there is no collision. So you can say that, OK, if you know that name and version, you can for sure say that, OK, this is the package. And it also has to have some data about these packages, like if you have a binary, how to get to its source package or source repository, what is its license and other things. But these are all not always there or not mandatory. Now here you have also another standard, which is VERS, or version range specification. This is the project that is also used in Google OSV for their own database. So for example, a lot of ecosystems, they have version range specifiers. So for example, this package needs and another package B that depends, that it is depending on, and they have a version specification that, okay, we need from version A to B. And the way that they define this is not always the same. Everyone has their own way of defining version. So this normalizes and makes sure that we can parse that data easily, and we can say, okay, this version comes inside this version range or satisfies this. So that is Perl and verse. Okay, so here we participate in Google Summer of Code, and we went to like the Mentor Summit last year, and it's an unconference kind of thing, and we have we don't have the talks specified there before, and so we had a SBOM talk there, and because there was a lot of people interested in, and we had this SBOM tags to show that you are interested in something, and then we were talking with someone, and they said that, okay, GitHub has a SBOM button, right? You guys are also doing SBOM, so why should I not go to GitHub and just click a button and get an SBOM, and then we are done with it. So GitHub does great SBOMs, and they also use scan code internally because GitHub uses a project called Clearly Defined, which was started in About Code, and Clearly Defined uses scan code as one of their primary scanners. So the license data that you see beside a GitHub project, sometimes that is given by scan code. So it is good for SBOMs, but what is the problem with this kind of thinking that, okay, we have a SBOM button somewhere, and we just click it, and we have a SBOM, and we are done with it. That is not great because it does not make you think about the software that you have and what is in there, and it does not let you think about the issues that could be present, why there is no good SBOM. So that is the goal of this talk, to talk a bit about that part. Here is we also have SBOM buttons, of course, in Deja Code and ScanCode.io and all other places. So here we are looking into a couple of issues that you face or that we need to look out for, right? So there's a lot of package manifests, right? These are your PyProject.toml or pom.xmls or any other kind of package manifests that are present out there. And there are a lot of them. And they keep, there are new ones of package manifests every now and then. So for example, our stack is in Python, so we know a bit about that. So the poetry, it was introduced in 2018. We have a new UV project, which is written in Rust, which is fast. That was introduced in 2024, which is just a year back. So if you see many of the open source scanners or other scanners, they need to catch up and make sure all these types of package manifests are supported. So a lot of the scanners, they are mostly depending on the package manifest or the log file, and they scan that and get a list of packages and sometimes relationships between them. So it is very important that all of these package manifests are supported. And there's a lot of package ecosystems out there. For example, package URL has 32 ecosystems and probably about 30 or 40 more which are proposed and could be more ecosystems, right? So these are the ecosystems. And then every ecosystem has a couple of package manifests, like Python has setup.py, setup.cfg, PyProject.toml. There's log files, requirement.txt, UV log. And it's not even just these package manifests. They sometimes have specifications and they have versions. So something new is introduced and you kind of need to support that. So these are the number of package manifests supported in About Code tools, for example. You have all the links here. So this is for package. The same is true for licenses. There is a lot of software licenses out there. So SPDX tracks them, and it is a list of licenses there. Now, there is a lot of licenses also in ScanCode license DB, and these are interoperable. And these have, ScanCode license DB is also mentioned in the Indian CERT guidelines or German BSI guidelines for SBOM, for example, because it's a comprehensive list. So you have ScanCode license ref, which is like SPDX tag, which is used to support between these two. There are links for all of these. Now let's look at a couple of places or ways you can generate SBOMs, right? So there are many kinds of SBOMs, like source SBOM, deployed SBOM, like build SBOMs, analyzed SBOM. So what is the difference between these? You know that story about like the elephant and a blind person only touches a tail and then says, okay, this, and someone touches a leg. So this is like that. A kind of build SBOM process only has a view of one part of the ecosystem. For example, if we are having like source SBOMs, it only looks at a repository, and it looks at the source code where all the activity happens, someone maintains and contributes to it. So it sometimes has requirements which say which packages it needs, or it sometimes has a lock file which exactly pins the packages. If there is not a lock file, you need to use package resolvers. Like for example, pip install resolves these packages for you. Now, there are many resolvers that we maintain or like other tools maintain. They do similar things, but there are many cases where the version ranges could, or the exact versions cannot match based on when you are doing the resolution. Because if you do a resolution 2 days later, there might be a new package and that could evolve, right? So package resolution also depends on which OS you are in sometimes, or other factors. So that might not have the exact list of dependencies always, right? If you don't have a log file. That is why we recommend log files in source repos, because it at least gives you some control. But libraries cannot have log files because they need to have specification between like versions, right? Another thing is the CI/CD, like GitHub Actions or something. They have dependencies. They have a long list of dependencies inside GitHub Actions that is used to build and run that GitHub action. And these can also have vulnerabilities. Like for example, a couple of months ago, there was the TJ Actions software supply chain thing, right? Which was a vulnerable, someone has a vulnerable like thing which was pulled in the CI GitHub Actions, and that was causing many issues for a lot of organizations. So you need to really think in that sense, because the source is where this CI is also set up. There are also sometimes monorepos, which are like many packages aggregated together. So for example, one same repository would build a Python package, a macOS or a Linux kind of package, and sometimes a JavaScript if it has UI or something. So it all comes from one repo. So you need to really think for this package, what is the subset of source? What is the source that it is being built from, right? And another thing is maintainability. Is the software being actively maintained? When is the last commit? How actively it is maintained? Are there best practices involved? All of that. We have good projects, open source projects, which help doing that, like end-of-life date and OpenSSF scorecard. We integrate some of this, like the OpenSSF scorecard is now integrated in ScanCode.io. Another place where you have SBOMs is in the build phase or in a deployed phase. So in the build phase, this is your CI, or where the source is being built into a binary. So this is for Java, this is like .java files are being compiled into .class files. For JavaScript, it is compiled into compiled JavaScript. So here, the binaries only have the bare minimum amount of things that is required to run the code sometimes, and nothing else. So that is not helpful, because if we look at a binary, because always the binary is the code that is deployed. So we need to, let's say, look at where is this code coming from, or what is its origin. So then we don't have that information. Like nowadays, a lot of extra information is also being built in the binary, which is a good case, because in that case, you have traceability. That, okay, this binary is coming from this part, built from this source, and that gives you more transparency and be able to know what's in there, right? So in containers or like big apps, there is a lot of packages and binaries being built. So the scale is a bit large, and we are having in organizations many projects that they need to generate SBOM for. So this is why the SBOMs need to be, like machine readable, so that anyone can cope up with that scale, and you can very easily identify, okay, is this SBOM schema correct? The package URLs in there, are they correct? Or you can very easily verify. Or let's say you want two tools. One is doing licensing, or one is doing security. there needs to be some interoperability between those. And SBOMs are where like these kind of data interchange formats, where this data is used in many different tools or many tools in your pipeline, right? One thing is that we have a project called Back to Source, which looks at binaries and code. And there are many techniques to do matching between them to tell exactly what is the source that is being built into this binary. Many times the binary has paths from which it is compiled, so we map back to that. Many times you can match by class path, for example, Java. JS you can do also. And then in many cases, which we are experimenting is with extracting symbols from both the source and the binary. Symbols are, for example, variable names or function names or other things. And sometimes it is present in binaries or other things. So you can use that to kind of map between source and binary. And by doing that, you know that, okay, are there other binaries that are being built into the thing, which you don't have the corresponding source code for. So you need to review them. So this is trust but verify. And then reproducible builds are always great. So you can know exactly where the binary is coming from. So it is coming from this CI being built on this version. And so if you do the same process again, the same thing will come out with the same checksums and a lot of that. So that also helps traceability, and you know where to go to find this code, right? There are immutable releases and SLSA and attestations which help with signing, so you know that who is doing this, releasing this software or something. So that adds an extra level of protection. So this is how, like that's why the build place is a great place to generate SBOMs, because of course the builds happen on every release and all of that. So you generate it automatically, and then the build, it knows both things. It has access to all the dependency lists where the code is being fetched from, all of that. It also has access to the binary which is being generated. So you can help put more metadata in the binary. So that is one thing. And most of the time when we do a SBOM kind of thing, we look into it. It's kind of a deployed binary, and we look into that. That is a bit harder because you have to do special things and to understand what is in the binary, because of course binaries don't have much metadata as compared to source or other things, right? So this is a CI that we have, scan code action, which has GitHub Actions and support for Azure, and Jenkins and other things are also there. Not everything is declared in the manifest, right? So you have all other things, right? Like for example, something is vendored. So not always do you want to use a whole dependency, right? The package manifest lists the dependencies, but there are many dependencies which are not defined there. So if you, let's say there is a package, you want to only use one file or one portion of it, and you don't want to put up with all the baggage and dependencies that come with it, and all the risk, right? So sometimes what you do is you vendor a part of the code. So in that case, or in some case you copy a part of a function or somewhere. These are not included in the dependencies. If you have a binary that is needed to support for other OS or other ecosystems, that is also not included in the package manifest or dependency list. So you need to go beyond the package manifest to think about dependencies. How we can do that? So we have matching. So like you have an index which is built on all the package archives, and file trees and just files, and then also snippets of code. So whenever you have something on the source or binary side, you can always match using checksums. This also helps us to avoid rescanning the same package again and again. So for example, the first time you look at a package, you scan it, you index it. The next time, the first step you do is you match. And if it matches, you just pull the metadata that was generated previously. And that helps you avoiding rescanning, and helps with your carbon footprint also, which is quite nice, because even in other organizations, like you have one organization which runs the scan, other organization has to run the same scan again. So if there is some general place where all the organizations collaborate on the data and all of that, that becomes very useful to not run the scan again and again, and also use the curations. There are many projects like for example, clearly defined or Ocelot, which provides you these curations or data. We also are doing Perl DB, which we will look at later, and federated code, which gives you the data in a federated manner, similar to like ActivityPub or Mastodon, those kind of, like they also use the ActivityPub protocol, right? So copying code. We do copy code. I copy code, everyone copies code, because it is useful to not reinvent the wheel. Sometimes someone has already done something which is well tested, well depended on. It is useful to take that. But what you need to do is like say where this is coming from in a machine readable fashion, so the scanners do it, so that you don't have to always say that, okay, this is being copied. For example, we have something called an about file, which lists the package URL, the copyrights, the licenses, and the origin of the code. So you have homepage URL, or you have some URL that tells you exactly where the code came from. Because this is not listed in the dependencies, this helps you put this on your SBOM and also declare it responsibly, so you can generate attribution and other things, right? So it also helps you to update it, because you can just write a script and go fetch the same thing again and see if it is updated and run tests that it works, right? And sometimes if it is not, all packages are not modular. So sometimes you can help upstream, right? So you can release that small part as a modular package, so others can also reuse that, and that is maintained, instead of just having this on your code, because then it is not maintained that much, because that is not in focus, right? So if all of this is not there, then we have to match. Then we have to do checksum-based match or other kind of matching to see what kind of code is there. Another thing is AI-generated code. AI is very helpful. It sometimes helps very much with boilerplate kind of code, or if you're doing new things. It does a lot of hallucinations and other things which probably will improve or not, we don't know. But the reality is that AI-generated code is very much there, being used in all organizations. And the thing is that the copyright-specific issues or other things are not very clear yet. They are still being fought out in the courts, and they are being discussed and all of that. So we still need to match these, right? Because if you see, a lot of these AI models are trained on public data, and many of them have license and other things. So we need to look at something and be able to say, like for example, GitHub. GitHub, for its GitHub Copilot, provides a feature that you can find the corresponding public code if it matches, which tells us the reality that it does match with public code. And it maybe the variable names are a bit different or something, and it has changed it a bit, but it is similar. So we have an approximate snippet matching algorithm, which works for that thing. So it abstracts out a lot of things like variable names and strings and white space and a lot of other things, strips that away, has the control flow of the code, and does a fingerprinting based on that. And it does that on both sides, on both source and the thing that you match for. So it helps you find AI-generated code. Then also we have we have collaborated with Hugging Face on LLM that is trained on permissively licensed code. They use scan code to scan for permissively licensed code. And here, they also have a third version coming out, which you are collaborating on. And they also have a stack v2, which is a collection of all permissively licensed code. Now, another thing is like in binaries, if you look at binaries and you are trying to find what is in them, it is a bit hard for us to just build around tools which does a lot of hard things. The easy thing to do is just include metadata at the binary and at the specification level. For example, some ecosystem is bringing out a new specification or a binary or something. Like for example, here Rust Foundation, you can do a cargo build and build a Rust binary from a Rust code. They have introduced a new thing called cargo auditable build, which includes the dependencies metadata in your binary. So this is being fixed at the source. So if it is fixed in the source by foundations and ecosystems, then it becomes a lot easier for us, because you don't have to build tools to over-engineer things around problems that we have. So of course we have the also Python improvement proposals, which says that you can specify external dependencies in your PyProject.toml. This is still being discussed, I think. So this is like libraries or binaries that you include in your code. You can mention in the manifest, so that even though it's not like the manifest is not used to fetch those, it's a nice way for transparency. We also do that. For example, my mentor Philip and one of the original authors of the tool, they have the largest deletion in Linux kernel commit, which was mostly like code and like not code, like license comments and a lot of those things. So we help them remove and clean up and replace them with SPDX license identifiers, which are much nicer as expressions. Philip also helped the Python enhancement proposal with like in the pyproject.toml or other Python metadata, you have a license expression now. Previously, it used to be a bit ambiguous and you had to do other things. But these things help the whole ecosystem with minimal effort, because that fixes things at the source. And that's what like us as an open source organization are able to help with more of that, because we are an open community and we can help fix the licensing issues. So we do massive scans across ecosystems, and we provide that open data. So that helps us identify the gaps and fix that at scale and at source sometimes. And we are doing this with, for example, Maven, Rust, and a couple of other ecosystems. For example, we are looking for, in Maven, there is a project, we are working with the Log4j maintainers to detect binaries or binary versions of Log4j that are still present in many Maven packages. And the number is in thousands, which are still present having vulnerable versions. So there needs to be a better outlook about these things. How we help is, of course, we are a non-profit, fully open source, open data. We also have public instances for our tools, so anyone can go and check how things are working. We are soon setting up a foundation with other projects in this space to help fund these open source development and maintain these projects. So that helps us. For example, Linux has a foundation, Python software has a foundation, and that's a great model to help projects, open source projects. We have CLI tools, GitHub Actions, web app, whatever there is like containers or source binary scanning. We do all of those. So we have CLI tools if you prefer that. We have APIs if you're integrating with other tools. We have web apps that you can deploy on your own or use our public instances. So there are a lot of options that is there. We are also having a large community. Of course, we cannot do this on our own. We get a lot of bug reports and PRs and other help from a lot of organizations that are using those, and they help us find issues better and build better packaging for that, because like all the licenses which are curated and collected, we get a lot of help from the community. Otherwise, it is very hard to build a nice tool without that community help, because there is a lot of things to support and look for. This is the About Code stack. We have another session after this. We'll put up the links for that. That has a live demo. But this is the stack. At base, we have the databases. So license database, package URL, which has package metadata, and then vulnerability database, which are for vulnerabilities, right? And then it goes into scancode.io, and then it goes into data code. So who's using it? Other FOSS tools, and yeah, we need your help. And that's another talk which is starting. I should go there now. And yeah, that's all. You have link to slides. And if you have questions, I'm not sure we have time, but I'm not sure anyone is there. Is anyone from the LFX here to stop the presentation or anything? No? Okay. Anyways, any questions? I think that's all for this talk. You have also this talk that's going on in 01 and 02. So, hey, thank you everyone for joining in. And if you have any questions or anything, let me know. And I have my LinkedIn and GitHub and everything pointed. So if you want to have discussion later on anything that we talked about, please let us know. And have a nice day. Enjoy. Make sure you have some Hyderabadi food if you are not from Hyderabad. It's great. And yeah, have a nice day. Enjoy.